I modded my Canon T3i DSLR for Astro some time ago. I replaced the IR cut filter for full spectrum. I wanted to TEC or peltier cool the CMOS sensor for lower noise. My goal was a regulated CMOS sensor of 40F with ambient temp of 70F or lower. I could go lower temp, but then need to deal with dew. This can be done with dried air or heaters. Camera mod. I did not like the idea of cutting up the camera case and removing connectors, etc. like most other DSLR cooling mods are done. I came up with packing thermal transfer pad, GapPad brand, from the back of the sensor PCB to the back plastic case of the camera in the LCD pocket. Yes, cooling through plastic has thermal resistance, but it turns out this is only around 12 degrees Fahrenheit, approximately 6.7 degrees Celsius, delta across the plastic and to the CMOS sensor. Pros: looks clean, not butchered like most other cooling mods I have come across. Cons: more thermal resistance to get the heat out of the sensor. TEC testing without PID controller. I typically shoot 5-minute subframes for hours at ISO equals 800. Setting this up in the 70F degree lab, after 25 minutes the sensor stabilized at 95F. The CMOS sensor is burning about 1 watt when shooting continuously. I first used one 12-volt 60-watt 40 by 40 mm TEC and ran it with 3 TC or thermocouple, one on the CMOS sensor and one on each side of the TEC. Running at 12 volts, 5 amps, 60 watts, was a total failure. The sensor actually got hotter. I lowered the TEC voltage, things got better, so I kept dropping the voltage. After this testing, I wasn't getting the temps I wanted. I stacked another 60-watt TEC for more thermal delta. Things got way better. I ended up using 3.5 volts per TEC, 7 volts when wired in series, and about 8 watts total, driving 120-watt total TECs, without PID controller, just full on. With this setup, the uncooled CMOS sensor in a 70F21.1C lab, the CMOS gets to 95F35C, continuously taking 5-minute subs. With TECs turned on, it gets to 55F12.8C, a 40F22.2C degree lower temp. The difference is pretty dramatic in CMOS sensor dark noise. I used this for a couple years. The downside is the CMOS temp is not regulated. As the night cools down, so does the CMOS temp. Around 40 degrees Fahrenheit drop from ambient temp. This causes you to need dark frames for the different CMOS temperatures. PID temp controller. Adding a TEC controller to regulate the CMOS temp. On AliExpress, they have PID temperature controllers RX C100 for approximately $10, with K thermocouple and solid state relay included. What a bargain. I did not use the included TC or SSR because the TC is huge braided cable that won't fit in the camera, and the ACSSR is not needed. I just used a IRFZ 48 NNFET to control the TEC current. From previous testing, I wanted to run the dual TECs at 3.5 volts each, 7 volts when in series, so I added a DC-DC to set the TEC voltage to 7 volts. I lowered it after PID tuning. Looking at the temp controller settings, 1. The fastest the PID loop cycle is 1 Hz on this controller, so I set it to that. 2. This controller is set up for heating. I want cooling. So I picked off the inverted signal after SOT23 FET driving the SSR output. But this causes the TEC to be full power when making PID adjustments, so I added a TEC-enable switch on the back. 3. Can access all the settings functions in the Rex controller looking at the manual, probably different FW for different PID controllers. Modifying the controller. I did not need the built-in AC-DC 120-volt AC to 12-volt converter. I also didn't want 120-volt AC coming up to the camera area, or the alarm output relay function. So I removed some components, AC adapter transformer, alarm relay, and a few more components to allow room for modding. That opened up the whole middle of the controller to add the TEC DC-DC and control FET inside the PID controller, saving external components. Seeing all that room, I figured why not add a second DC-DC to power the camera. This will eliminate the separate camera ACK adapter and its wires running up the mount to the camera. So I added two DC-DC, one for the tech power, one for the camera power, and a IRFZ48 NFET to turn on/off the tech power via the temp controller. Also added reverse polarity protection for the system, a diode across 12-volt input and inside the camera battery adapter in case it's hooked up backward to the DC-DC camera power output. This opened up temp controller rear terminals for other uses as seen in the pictures. First testing of the PID controller. The first issue was when I first connected my K-type TC that was installed in my T3i camera. The controller displayed 23 degrees Celsius, all looked normal, but it would not change temperature when cooled or heated with the tech. Tried another K-type TC and the same. I tried other KJ and T-type TC and all would not change temp when connected to the PID controller, well until I touched the TC to a soldering iron. I reverse engineered the TC amp schematic and all looked fine, so I changed the gain of the TC amp from 100 times to 1000 times by changing R9 from 200 kiloohms to 2 megohms. Now the temp changes when camera is heating up and drops when tech is turned on. Now it's able to do its function, and this allows the meter to be way more sensitive. Currently around 5 digits on the Rex display is around 1 degree F. Downside is that it throws the real temp readings off, so I made a table of real temp to display temp, and it's set it and forget it. PID tuning. Once I got the temperature reading to work, now was the time to test and tune the PID controller, plus setting tech voltage. This also acts as a second P gain. I am using scope current probe to monitor the tech current, PWM waveform, and tune the PID loop. After testing, I ended up with a tech voltage lowered from 7 volts to 4.2 volts, 2.1 volts per tech, so only burning about 6 watts of tech power now with 70 F ambient temp to get to 50 F. It takes around 80 seconds to go from 95 degrees Fahrenheit, 35 degrees Celsius, to 50 degrees Fahrenheit, 10 degrees Celsius. Pretty happy with it now. I could have added a H-bridge to cool and heat the tech. It should regulate better, but burn more power. Part of the problem is the 1 Hz update rate. Currently, it is regulating about 1/4 degree Fahrenheit. I think that is good enough.